The diamond is considered to be the hardest of all materials in nature. But even the strength of diamonds is challenged by a manufactured substance known as boron carbide that's used in the production of protective body armor.
Boron carbide has a hardness approaching that of diamond. It has a stiffness factor that's twice that of armor-grade steel. And those properties are what really come into play when the projectile impacts that ceramic hard facing.
In addition to being hard, boron carbide is light, making it ideal for use in combat.
Weight is often referred to as king in the U.S. military. Make it lighter, make it faster, make it stronger. They want their soldiers to have to carry the absolute minimum amount of weight for the maximum amount of protection.
This recovered video taken from an insurgent sniper's vantage point shows a U.S. soldier exiting a military vehicle. A shot rings out, and the soldier goes down. But he miraculously rises, unharmed, and steps to cover, thanks to his boron carbide armor.
This is the current MTV, Modular Tactical Vest, being fielded by the U.S. Marine Corps. The finished boron carbide plate sits in the front plate pocket. The armor is completely backed by soft armor for fragmentation protection, drop armor for groin protection. On the side, we have additional integrated sight plate protection, side armor. And then on the back, we have another plate pocket for another boron carbide full plate.
Boron carbide armor is a ceramic formed from boron carbide grit. It's not a naturally occurring mineral, but has to be synthetically created by combining boron oxide and graphite. To make ceramic armor from boron carbide, manufacturers use a system that's known as hot pressing.
It's commonly dry pressed using high tonnage presses to form the initial ceramic shape of the armor that you want. The material is then put in a non-oxygen atmosphere furnace, heated up in temperatures that can be in excess of 3,900 degrees Fahrenheit, at pressures up to 1,000, 2,000 psi. And you wind up with a hard, granular material where the grains are distinctly bonded together with no cracks. It's one solid material.
Even though boron carbide ceramic armor is extremely hard, bullets don't just bounce off it as they would off a steel plate. When a projectile impacts the face of the armor, the ceramic actually fractures, absorbing some of the energy. As the projectile penetrates the ceramic begins to pulverize into very fine grains that act as an abrasive, wearing down the projectile. A high-strength ballistic fiber backing helps catch fragments and distributes the pressure of the impact. Protective Products International in Sunrise, Florida, manufactures both boron carbide and soft body armor. There's only one way it can test the true strength of its armor, and that's on the firing range. A panel of aramid ballistic fabric used in soft body armor is strapped to a clay backing, which will simulate the bullet's impact on the human body.
This here is a universal receiver. This is what we use for our testing. We're able to use the various different handgun barrels from here, the 357s, 9mm, 44. So that's why they call it universal receivers, because it's equipped to handle the various rounds.
The universal receiver is loaded with a 9mm round and fired at the aramid sample from a distance of 16 feet.
The shot impacted right here. We're going to take a look at the impact, how it affected the panel. As you can see, tore the cover, but the bullet did not penetrate, and that is the indentation that it left in the clay. You can see the back here, the fabric of the liner tore, but it did not penetrate the ballistic woven fabric.
But ballistic fabric can't stand up to the impact of a high-velocity rifle round.
What happens against high-velocity rifle rounds with a sharp penetrator nose is the penetrator actually begins to erode and, for lack of a better term, wiggle its way through the fabric. So it finds the weave points, it finds the points between the fibers itself, and literally wiggles its way right through the soft armor.
But what happens when that high-caliber rifle round meets boron carbide? Protective Products International will compare boron carbide armor to a ballistic-grade steel plate. The steel plate is wrapped in Cordura fabric to contain spall, the spray of bullet fragments after impact. From 16 feet, a marksman fires a 7.62 by 39 round out of an SKS, or AK-47 equivalent.
Here's the ballistic steel plate after the impact from the 7.62 by 39. As you can see, a lot more shrapnel flying around. Small little dent there on the side. No dent whatsoever in the clay.
Steel plates became a thing of the past with the introduction of lightweight boron carbide armor.
This is a boron carbide ESAPI plate, the equivalent of what's currently being fielded by our U.S. troops. It is a multi-curve design designed to fit anatomically on the body. That is why we're shooting this on a mannequin. Weighs roughly 5.5 pounds as opposed to the 9-pound steel plate we just shot.
The marksman fires a 7.62 by 39 round from the SKS.
To the naked eye, the impact looks a lot more traumatic. However, that is exactly the way the ceramic is supposed to function to defeat the threat. As we remove the plate, there is a slight dent. That is the back face signature that it creates. However, it is not that significant.
The marksman shoots the ballistic steel plate with a .223 round fired from an AR-15, the equivalent of an M16.
Pull the plate out. You can see a little bit of a dent. A lot of shrapnel went flying. Virtually no impact whatsoever on the clay.
The boron carbide plate receives a similar .223 round.
Once again, the second impact by the .223 round looks visibly a little more traumatic than the impact on the steel plate. However, again, that is the way the ceramic is supposed to function. Remove the plate. You can see the cone of impact. Basically, the ceramic shattered the round. Back face deformation. You can see a small dent in the panel. In a head-to-head comparison between the ballistic steel plate and the boron carbide plate, they are both equal strength. The boron carbide plate does it at 25 to 30% lighter weight.
Boron carbide is on the verge of becoming even stronger and even more versatile, thanks to breakthroughs made by Dr. Robert Spire at Georgia Tech University.
In addition to being able to make it to a higher density, we developed a method that wasn't shape restrictive, and so that we could make complex shape parts that were also theoretically dense.
The high-pressure method currently used to produce boron carbide armor necessitates that the plates be relatively flat.
Because we're able to make complex shapes, we can make added protection, for example, for a shoulder, thigh protection, helmet liner, etc. We're working on prototypes for that.
This research is in its early stages, but there's no doubt that super strong, super light boron carbide represents the future for protective body armor.